Hello. In this video, we will be doing right triangle trigonometry. So right triangle trigonometry is very useful to know, and it comes up in many real-world applications, such as angles of elevation and angle of depression and so on. So when we deal with right triangle trigonometry, a key concept is SOHCAHTOA. That is, sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. So, and we, of course, theta is the measure of an acute angle of a right triangle. And the key concepts are given here in this box. And we also need to know Pythagorean theorem. That is a squared plus b squared equals c squared, where c squared is the hypotenuse. A and b are the smaller sides. Okay, let's do an example. Let's solve, let's make this a little bigger. And we are going to need to solve this triangle. Example 1 is called FGH, the triangle, and round the measures of the sides to the nearest hundredths and measures angles to the nearest hundredths of a degree. All right. There are no units for the sides. So what I'm going to do is we're going to use the concept we were given above. So in this case, we can say sine of 70 degrees, that would be the angle at G, equals opposite over hypotenuse. In this case, opposite is 18 over F. So we're solving for F in this problem. So then F, if when I cross multiply, I have F sine of 70. Sine of 70. This equals 18. All right, so F equals 18 over sine of 70. Let's grab our calculator and see what that is. Go ahead and grab my calculator. So we have 18 over sine 70. So F, let's put this to the side. F equals, I believe it was 15.66. Sorry, 19.16. Sorry, F is 19.16. All right, so we've solved for F. Now we can solve for H, and that will be capital H and lowercase h. That's all we need to know in this problem. F is already known. That's 90 degrees. So let's solve for lowercase h. So then we have tangent of 70. This equals 18 over lowercase h. Because by SOHCAHTOA, TOA is tangent of theta equals opposite over adjacent. So that's what I'm using here. So therefore, that means h equals 18 over tan of 70. So h then equals, that's not what we wanted. Okay, so 18 divided by tangent of 70 is 6.55. So 6.55. We are rounding to the nearest hundredths, and I need to double check if that's in case. Yeah, indeed, yeah, that is the rounding, the correct rounding that we need there. So now for capital H, capital H is actually known. Capital H, in this case, we can find that rather quickly. H equals 180. H. 180 minus 90 plus 70. We already know the angle at F, the capital F, is 90 degrees. It's a right angle. And we also know that the angle at G is 70 degrees. So the sum of the angles of a right triangle equals 180 degrees. So subtract those two numbers from 180. We get 180 minus, this looks like 160. So H equals 20 degrees. All right, so therefore we can come down. So I have found FGH. So F is 19.16, lowercase h equals 6.55, and capital H is 20 degrees. All right, so that's example 1. So example 2, this is another similar problem that requires Pythagorean theorem and right triangle trigonometry, SOHCAHTOA. So this is a famous Pythagorean triple, 5, 12, 13 triangle. In this case, assume we don't know the hypotenuse and we want to solve the whole triangle. So assume that we know only two sides, and we're solving for the hypotenuse as well as the angles B and A. So in this case, the hypotenuse is C. C squared equals 5 squared plus 12 squared. So C equals square root of 5 squared plus 12 squared equals square root of, this is 25 plus 144 equals square root of 169, and this equals 13. So C is 13. Let's come down and solve for A, angle A. So here, for angle A, I'm going to use tangent of theta. So we have tangent of A equals 5 over 12. So then A equals inverse tangent of 5 over 12, arctangent. So this equals, this is going to be a rounded number, equals, let's see, we're going to grab our calculator. Let's do second tangent, 5 over 12. So rounding to the nearest hundredth, we get 22.6, let's go back, 62. Okay, so that's angle A. So now that we have A, and we already know angle C, so angle B, so this is measure of angle B. Measure of angle B equals 180 minus, this should be a degree symbol there, angle C is 90 plus 22.62, so equals, let's grab our calculator again. So let's do 180 minus 90 plus this number is 67.38. All right, so that's how we solve it. Let's do a last step here. So we have angle A, measure of angle A equals 22.62. Measure of angle B equals 67.38. These are rounded numbers, so let's put that symbol in there. Okay, and then we said C equals 13, and we don't know what the units are on C. All right, so that's how we do right triangle trigonometry. The problems here are basically all you need to know about right triangle. Of course, you will face other problems. You will need to know cosine. In this example, in these examples we didn't use cosine of theta. I only use sine and tangent, but it is a similar concept. The ideas are the same, and we will use Pythagorean theorem occasionally to solve for a longer side or a shorter side. And then we will be using SOHCAHTOA to solve the angles or sides. And so in the next video for right triangle trigonometry, we will create a Python program that will solve for us without us with us only needing to input the known sides. In this case, for example, we know the sides are 5 and 12. When we enter that, our program will calculate C and the angles A and B. And for a similar setup for the first example. All right, so this is right triangle trigonometry. Thanks for watching.